Well, it's really exciting to be here and speaking with everyone today. We are huge fans of Airflow, obviously, and it's really cool to see the community come together, at least virtually, in an event like this, but excited to present our solution and how we're tackling some problems within this ecosystem. So quickly about Databand. Our company was founded in 2018. We're now a touch over 20 engineers. Our team is a group of data and machine learning enthusiasts with experience in startups and big enterprises. Before Databand, I personally was a product manager at a big data startup called Sisense. As a PM at Sisense, I relied on our data engineers and our pipelines to get critical data we needed on a daily basis. And from my experience working with those engineers, it was really easy and quick to understand how underserved this is as an area. And we were, myself and my co-founders, very excited to forge new products in this space. My co-founders themselves, both data engineers, and together we really set out to create a solution that would make data engineering easier. We started building our product, raised some capital to help us grow, and are now working with some very forward-leaning data teams. I'm excited to share more about our solution to the group. So we are obviously very excited and invested in Airflow and the community. We're contributors to the open source at Databand. We're helping to make Airflow more performant and data aware in particular. These are two main priorities for us with the project. And most recently, we actually collaborated with Gerard from Twitter, who gave a great presentation last week, as well as Polidia on AIP 31, functional DAGs. It's a great feature that simplifies the DAG authoring process and will be included in Airflow 2.0. We just released a blog post on this. Definitely encourage everyone to check it out. But our latest contribution into the project that we're excited about. So at Databand, we really focus our time on this question. How can we help data engineers achieve better reliability for their pipelines? Reliability is important because data engineers serve really important business functions. Most companies are depending on quality, timely data for critical operations, decision-making, and even revenue in increasing cases today. And data engineers are really the backbone of these activities. Now, every data engineering team is in a different stage of development. Most companies we see are still building out a lot of their infrastructure, but once you have those pipelines running, what you need is to make sure that you can depend on them. This is always the next step in the process. And this is really where observability comes in. Observability being essentially really deep monitoring of a system. We think good monitoring and resilience are big reasons why Airflow gets selected in the first place. So this is probably already on every Airflower's mind in some way, but for a lot of teams, we feel like more really needs to be done. So what is observability for data engineering? Well, we look at this as a pyramid of needs, with each level of monitoring providing more of the full picture that's really needed to know that your entire system is reliable. On the ground level, there's monitoring executions. This is like seeing whether there's any flow of data at all. Has the execution failed? I mentioned I used to be a PM in a data product team. We relied on daily usage information from our client base. This is how we knew whether features were working and where to focus our development efforts. So we really depended on those pipelines to function properly. And if we didn't get data back from our clients, that was pretty much the end of the road for us in terms of analyzing that information, obviously. So we wanted to know as soon as possible if our pipelines weren't working, and we wanted to immediately find those errors when they happen. After basic execution, there's latency. So even if my pipelines finish, if they're finishing too late, the data might be unusable for the end business users or the end consumers. In product, we made daily decisions based on that usage information. And getting data from last week or previous weeks was better than nothing, but not by a lot, because new features rolled out so quickly within our application. We really need timely data in order to analyze it. Next level, when we know that the pipelines are functional and the data is being delivered on time, we really need to know what the data actually looks like. So is it complete? Does it have changes in it that are important to know about? Are schemas intact? I wanted something to tell me right away if certain features spiked in usage, for example. And I preferred not to have to create new dashboards and new visualizations in order to find that information, especially when it's often immediately available. And finally, when we combine all these different levels of monitoring with how people actually work with the data, the question becomes, how are problems communicated across the team? I would have loved in that product team for one of our data engineers to tell me right away, hey, Josh, it looks like we're not getting metrics back from this particular feature, and we need to push a fix on the pipeline or on that feature code in order to get this data in, rather than me going back to those data engineers, days later, weeks later, saying, I have this graph on some Looker or Sisense dashboard that looks really weird, and are you sure everything is working back there? So, these visibility gaps, when they came up, were really frustrating for us as data consumers, even more frustrating for our data engineers as producers. Airflow itself, as we know, provides a lot of great functionality at, I would say, the base 2 levels of this pyramid, but often not enough, and obviously not the whole complete picture. So what makes this tough? Why is it hard to achieve this full pyramid of observability? Well, there's a few key reasons that we see. First of all, pipelines are way more complex today than ever before. It's a lot of infrastructure for teams to monitor, and Airflow is often just one part of a broader picture. In fact, we know that up to 90% of Airflow users are using it in conjunction or combination with other infrastructure services, often other services within different cloud ecosystems like AWS, GCP, or Azure. We also know that almost 40% of Airflow users use it with Spark. And Spark alone can be fairly complicated to understand and debug, and when you start combining these different solutions together, it can get pretty complicated. On top of that, each of these tools report statuses in their own way and really live in their own context. And today in most teams, we don't actually have a lot of great standards for how we bring together this information into like a single pane of glass where I can see exactly where errors are coming from and how things relate to one another and how metadata is correlated. So I might get my SLA misses from Airflow. I might get my Spark failure information from the Spark UI. Maybe I have some data quality measurements coming from some custom logic or another reporting module or some jobs running on a database or rules set within the pipeline itself, but often in its own silo. And resource information on top of that, how my cluster is performing, what underlying CPU or memory utilization problems might come up. This often comes from another system as well. All this stuff is very, very interrelated, but hard to see from a single vantage point, how everything stitches together. And finally, most organizations have limited data engineering resources. And congratulations to the actual data engineers on the call. You're now one of the most highest demanded engineering roles. That makes your time really valuable, and you should feel like your time is valuable. And there's a big opportunity cost to spending that time on infrastructure that may not necessarily be really core to your company's focus, or spending a lot of that time troubleshooting things even. And these are the kinds of challenges that we think about every day at Databand. How do we help data engineers ensure reliable delivery of quality data and use their time most effectively? What we created to solve this problem is a purpose-built system for collecting, organizing, and alerting on information that we see from data pipelines. So it's about helping you trace business issues like whether we have delayed data deliveries or corrupted outputs to specific problems in your pipelines, like are there resource availability issues that are causing things to fail, or are there input data problems, or are there task code errors? Seeing how all those internal task or internal data or system level issues boil up to actual business problems and how people work with the outputs that you're producing. What makes us really different than other tools that you might be familiar with in the market or kind of your standard crop of monitoring systems is we really focus on data pipelines. We built our system for the things that make pipelines unique. The periodicity of these processes, task interdependencies, different levels of infrastructure, multi-dimensionality of what you want to monitor and your task outputs. It's not just in our system how we think of things, not just about presenting a series of time series charts on how some metric or CPU is changing, right? It's about being able to see all of your pipelines, how many resources each is consuming, how that relates to data volumes, throughput, job durations, data quality, and ultimately your deliveries to your data consumers. How our solution works is by tapping into different levels of pipeline infrastructure and collecting metadata from these places. So what we'll do is we use various APIs in order to collect into the orchestration level, being Airflow, the task level where your tasks are actually getting executed, be that in a Docker container or on a Spark cluster, or even in a database like Snowflake, and then tapping into the actual data, the quality metrics or profiling metrics or completeness information that we see within the data that's being read and written by these different processes. And then making users aware of what's going on from this information that we pull out and organize in our system, helping you understand that a DAG you have might be running late because you have a Spark job which is under-resourced for the amount of data that you're trying to process, for example. Okay, so hopefully that sets up some good background for what our application does. At this point, I'm going to jump into a demo of the actual product so that we can see Databand in use and some, real feeling use cases. Okay, so switching into our application UI, here you can see basically the homepage of our system. What we see is we have a lot of different pipelines that we're monitoring. Most of these, I think all of these processes actually are being run from Airflow. We can also see our pipeline view of every single DAG that's running or even instrumented within an underlying Airflow from our scheduler view, where we can see what the day-to-day schedule of these different processes look like. Now, looking at this view here, what I can immediately call out as a user of the system is we have some DAGs in this environment which are very active, including ingest data for AutoBig, AutoLab, send input summary. We have a bunch of processes here that we're running on pretty much it looks like a daily basis. On top of that, what I can see is that there's a few pipelines where we have a bunch of failures and a couple of those where we actually have alerts that are generated, which you can see here from our alerting column. So what I'm going to do is I'm going to actually dive into a couple of these pipelines and figure out what could be going wrong here, which is leading to these failures and producing these different kinds of alerts for us. Starting with this AutoBig pipeline, ingest data for AutoBig. So what this looks like from the Airflow side, we can actually click into and see right here. I just clicked into one of our runs from Databand, and we can see from Airflow how this pipeline appears. We have very simple pipeline, a few tasks that we're running. A couple of them are Python operator tasks, and one of them is a Spark job that we're submitting. Now, what we can see back in Databand's UI is an alert that's been triggered based on, it looks like a failure of one of these runs. So let's go into that process and see if we can figure out exactly where this failure is coming from and how that relates to all the different infrastructure and data that is being operated on. So here you can see I clicked into that specific run of my pipeline, which was running on a specific partition of data. And going into, again, the Airflow side here, we can start to figure out from Airflow, at least, what might be happening here and where this failure might be coming from. So you see from the Airflow side, just like in Databand, we have a failure on this ingest part of our pipeline, the ingest task. Now, if I'm in Airflow, it may or may not go a lot deeper into this level of information that I'm getting. So if I have logs coming back from this Spark job that I can integrate into the Airflow UI, it may tell me what's going on within that Spark execution, but a lot of times it's even difficult to get the logs back from Spark because it's running in a remote system or a remote cluster. Now in Databand, first thing that we can do is essentially open up this process to see what the underlying jobs are actually getting run. So I have these operators here that Airflow is executing, but I can actually open up this pipeline and see from a more granular basis what functions are being run within these different tasks until my function that has failed. So essentially all these nested processes that you're seeing here are what's getting executed within this Spark cluster. If I click into the innermost function here, the innermost node in my Databand UI, you can see a output, a print of the exception that came from this Spark code that ran. And what you see is we have an error not being able to resolve a column. The column name is 10, that's my column name, among this schema of a data set that we are operating on, right? So that gives me the first hint of what's going on, obviously. We have some schema error within the execution code. Now, what we can do from here is actually go a little bit deeper. As mentioned, we're also collecting information about the data set that's getting operated on. So we can go into that data set and really understand what that looks like within the actual data that's getting operated on by this process. So I'm going to open up a preview of that input. You can see here we have that raw input going into this function, and that's a Spark data frame in this case. I can open up a preview of that data set, and just visually inspecting this data set, I can see we are missing a column here that should exist based on my code, right? My code is looking for that column labeled 10, and we can see my columns are only going up to 9. So now we have more information about what's actually going on and a better sense of the root cause of the issue. It's that our data set is incomplete, and that led to this error. Now, important to mention, in a production or real world scenario, due to privacy or data security constraints, oftentimes we want to scrub or anonymize or even leave out this level of previewing of data, but that can all be handled as sort of granular feature flags within our system. And we definitely encourage folks to think about best practices and how much visibility they want to get into within their pipelines. Now, what's the next step that we usually take is going back into all my different runs of this pipeline. What I probably want to do now is kind of compare this information that I just gathered with a successful run of the process. So you can see my most recent execution. We had a successful run. I can jump into that. I can go into this same function where the previous run of my pipeline failed, and I can see from this data frame, we do actually have that column within the data set. And that explains why my pipeline this time ran successfully. So within Databand, we can sort of compare across these different schemas and even issues within the pipeline data itself. If there's disturbances or incompleteness that might explain failures or degradation in data quality even. Now, next thing that I want to do if I'm actually working through this pipeline and debugging things and trying to set up a more resilient system is probably set up some sort of metric where I can capture what's going on within this data, because it looks like that's a routine cause of failures for me, the incompleteness of a data set coming back. So what you can see is I'm actually pulling out a metric from my data frames called column count. And you can see over all previous runs of the pipeline, I have a bunch of failures here where I have an incomplete column count being reported back compared to this complete column count from the successful runs. So probably what I want to do is set up alerting or another kind of alert that will right away notify me if there is a incomplete data set that's being generated within any of my new pipelines. And I can even go into more deep information from the profile of this data, like the number of distinct values, the number of nulls that are being pulled back, the standard dev within different columns. So this is the level of alerting that I probably want to set up due to the kinds of failures that are leading to this pipeline not being consistent and reliable. So let's go now into another pipeline where we saw other kinds of alerts being generated. We saw a couple of alerts also coming from this pipeline called TrainModel for AutoLab. And if we click into that process, we see a similar run list that's telling me what's going on whenever I execute this pipeline. And we see right away that we have 2 alerts within my most recent execution here. And just looking at the metrics that I'm pulling back, I can sort of already tell why I'm getting those alerts. You see we have a couple metrics that we're reporting in from this pipeline when the task code runs. And I can see that my performance metrics, this is a model training case, so we're looking at performance metrics from the model that's produced here. I can see that my performance metrics have a big degradation related to previous executions of the pipeline. My R squared and RMSE, which it's a machine learning metric that tells me how accurate or predictive my model is of a data set that I'm feeding into that model. And we can see in the most recent run, we have a big degradation here, and that explains my 2 alerts that I pulled out, which are watching those performance metrics. So let's see if we can try to figure out what's going on within this pipeline. Going into the run which had the degradation in performance, first of all, let's take a look again how this appears on Airflow. This is a much simpler DAG. We actually see this a lot in machine learning scenarios where you might be bringing in a training pipeline or a training process that a data scientist has created, and you encapsulate that as a Airflow DAG that you want to run on some consistent basis, or as even a task within another pipeline. But you can see just a very simple Python operator that's running my training code. So same thing that I can see from Databand side, but again, we can open up this pipeline and see on a function by function level what is actually being run within this Airflow DAG, what's actually being run by that operator. And what you see is we have a few different functions here that are nested, but the main ones to look at are we have a task that's calculating features, we have a task that's splitting our data, then we're training our model, calculating some metrics, and then validating our model and calculating some more metrics. Now, if I want to see what's going on that's producing these really low performance measurements from my model, what I'll do is click into that function within the graph and then actually probably pull out a example of an input or input data frame that's going into that pipeline. So what we can see is we have that same nefarious 10 column here, but in this case, I have no data going into that 10 column. So that right away to me should look pretty weird, especially if I'm working with this code frequently, that there's no values that are coming back within that 10 column of our data set. And just like we did in the other pipeline that we looked at, I'm going to compare that against a pipeline that has much better performance metrics. So let's jump into that process, and we'll open it up in the same way. Let's expand this fully, go into the same task, which is splitting our data, and let's see how that 10 column looks. Right. So we see within this earlier version of this earlier run on an earlier partition that the 10 column that we're looking at actually has real data in it. So something happened here where my column went from having real data to just being populated with those 0 values. So let's try to figure out if we can determine what actually led to that process. And by the way, if I wanted to find a easier, quicker route to pulling out that completeness information, another nice thing that I can do is just jump directly into histograms. So These would be automated data profiling that we're running within the pipeline to evaluate what's going on within these different data sets. And if I go down to my column named 10 here, what we can see is in this healthy run of the pipeline, we have a lot of good data coming back, right? And if I go into my failed or poorly performing data, and I go down to that same column, we have weird data coming back. So we're binning this data according to some range of values here, and we see that there's only one distinct value that's sitting within this column of our data set. So another way of finding out where this issue is coming from. Now, let's go back to finding out if we can determine where this problem is coming from and how the problem is getting trickling down to this specific training process. So going into that pipeline again, and I'm just looking into a single run of it. Let's go into split data, and we have our input file here. If we click on target operations of the input file, we can start to see some more information about how this data is generated, right? So this would be a in-memory example of a data frame that we're catching here and logging information from. If we go to the original input of the pipeline, we can also see the original CSV that we're operating on here, that we're picking up from our file system. So clicking on that same target operations button, now we can actually start to see some more interesting information about that original input file and where it's being produced. And what we can see is from our target operations table, there's another pipeline in Airflow, which is writing this data file into S3 in this case, or into our file system. So what we can do is we can actually click into that pipeline. So this is a totally another pipeline. We have no alerts set up on this pipeline. It looks like it's more or less performing consistently, but we do have one failure here. So let's try to figure out if we can determine where all these issues are coming from that's relating to that incomplete data frame that we're reading from our training process. Clicking into this failed pipeline, this failed process, we can see we have another DAG. It's a little more complicated. Let's collapse it and see if we can get an easier printout of what the pipeline looks like. Coming in from the Airflow side, here's the DAG, right? Now seeing that again from Databand, let's open that up and see if we can start to figure out where these failures are coming from. So, all right, we have this same key error issue where that column that we're looking for, this column is continually causing issues for us, right? We were unable to grab that 10 column from our data set in this earlier failed run. And we can see here that 10 column is missing, right? So that doesn't quite explain the previous issue that we saw in our training process where we had the 10 column with all those 0 values in it. So let's try to figure out if we can understand what happened. Now we had this failed process, then we had a couple of successful runs right after it. And if we go into the most recent successful run, and we go into that same step of the pipeline, just choosing a random step here, let's see if we can look at the outputs, and we see, okay, so this 10 column is showing up again, right? It's showing up at the end of our data set, and it has zeros inside of it. So what this starts to look like is maybe we had some change in the pipeline code, which was put in by maybe a data engineer who saw that the pipeline failed because the 10 column was missing, introduced the 10 column back into the pipeline, and just imputed some records into that to kind of force the data set through and make sure that this pipeline is successfully running. And what we can actually do also within Databand is figure out through our pipeline code if there is a issue there in the code that might be explaining this problem, and we can see it here by just jumping into another one of our functions. And we can see, so if we have some code here where if 10 does not exist within our columns, create a new column called 10, put some zeros in it. So it looks like, in fact, we did have some code where a data engineer essentially fixed the problem, but by incorporating some, directly hard-coded imputed values that allowed this pipeline to run successfully, but messed up the model that our data scientist is building because it's a incomplete and sort of incoherent data set compared to the history of our runs, right? So what we just went through is a lot of different metadata that we are tying together within Databand to show this example. First of all, we started with a pipeline where it's running a bunch of Python tasks, but also a Spark task. And we saw how we can collect out the error log from that Spark execution and see how it relates to an issue within the data that we're working with. The next example that we showed is this TrainModel function, where we have a pipeline that's running consistently, but all of a sudden our performance metrics really degraded. The reason that this is really important is because this model that we're generating is probably the end of the line in our overall Airflow infrastructure, in the sense of this model is now going to get productized and put into some serving system that actually serves as part of a product feature and is maybe even customer facing. So understanding how these issues stitch together and relate to the end result business process that we're producing here and how customers are interfacing with it is really, really important. Being able to understand how issues from the downstream pipeline relate to issues coming from upstream pipelines and how to stitch together this information is more of the complete picture that we're really looking for in order to resolve these problems. The last step that I would probably do, going through this example, I want to go back to my ingest data for AutoLab process. And this is probably where I want to start creating more kinds of alerts on the actual data set that we are operating on, just like we did with our big data pipeline. So I want to be collecting metrics out from my histograms, incorporating those into my alerting engine, making sure that I'm getting notifications if the overall pipeline fails and if the outputs that we're producing from this pipeline look okay and how that relates to my data sets. One thing that we didn't touch on within this presentation so far, within this demo, is tying in resource information into these executions, but it would essentially work in a very similar way. So I have another pipeline here with just a few runs. This is a Databricks process, a little more complicated, but just like we're pulling out metrics from the underlying data sets, we can also pull out metrics from the underlying system resources and understand how those are changing, whether they're spiking, and if it might relate to issues that we're having with job durations, right? So being able to tie together my system resources, the amount of data that I'm reading, and my SLAs, so I have a full picture of what's going on. Okay, so hopefully that gives some flavor of the value that we're providing within Databand and how all this information gets stitched together within our application. I think with that, I will pause here and maybe just sum up what we saw so far. So what we're doing, our main goal within our company, it's helping data engineers manage more reliable pipelines. And the net effect of this is basically helping teams create more trust in their data. At this point, would love to field any or all questions that are coming from the group, and happy to dive into it. Okay, so I see one question here about if I'm already running Airflow, how does the integration of Databand work? Great question. So what we emphasize in delivering our product is that we really want this to be as smooth a process as possible. We want it to basically be an instant setup of you bring your Airflow, we plug in our API, and then you have this kind of visibility and monitoring. Essentially how it works is on a few different levels. The first one is would be being able to pull out the Airflow side information, which we do through an API coming from Airflow's official plugin framework. The second level of data that we can pull out would be coming from more of the task internals. So this would be like what's happening within my Python code, what's happening within my Spark code, what's happening within Java, Scala. How we integrate on that level can be through a couple different means. First of all, we have ways of wrapping Airflow operators. That would be essentially an automated method to pull out profiling information from your data sets or different information that we can get from the task engine or system where a operator is running a job. We also provide a direct API that you can embed within your task code that just logs information into the Databand system. Essentially, a few different methods of pulling information out, but very flexible, and that end of our product is also open for our customers to extend and build on with their own custom infrastructure levels if they have them.
Great. All right. Thanks, Josh. I'm going to jump in and read the questions to you so you don't have to do that yourself. Josh, would love to hear, answer all your questions. So please ask more down either in the Airflow Slack or directly in Crowdcast. Hit Ask the Question button at the bottom of your screen. There's a question from the community. Is the Databand product reliant on a specific infrastructure, e.g. Spark would need to be being used, or is it configurable?
Great question. We are decoupled from any particular infrastructure. So it's similar to using a standard kind of monitoring system like a Datadog, but what makes us really different again is how we build our product to really reflect and mirror how pipelines work. But similar to Datadog, we have abstraction out from the particular infrastructure that you're running. Now, within my demos, I like to use Spark because, first of all, it's really common within Airflow users, but it also is a great way of showing how different levels of the infrastructure stack create their own information silos and how we can sort of bring these things together. But if you are not using Spark, if you're just running Airflow on Python, even if that's in a single Airflow environment, you can still use our system to monitor what's going on. If you're using Airflow with running Redshift jobs or running Snowflake or running BigQuery, Postgres, number of different databases, even if you're using Airflow to kick off like Jupyter notebooks, we can also instrument within those pipelines and pull out information. So this is very decoupled to your infrastructure. I think what is potentially more interesting for people using our solution that are invested in Airflow and some of the tools that I've mentioned is within Databand, we have invested in a lot of deep integrations for automatic data extraction from tools like Spark and the databases that I mentioned in Kubernetes. So that sort of cuts down on the amount of metrics handling or configuring that you need to do in order to get information out if you're using these systems. But we're fairly abstracted out and can handle many different kinds of infrastructure. Also, I will mention, we love Airflow. It is the primary tool that we see within our client bases, but we don't necessarily also have to be watching Airflow processes. If you have DAGs that are run by another orchestrator, or you have pipelines that are ad hoc and not run by any orchestrator, maybe you just have some Python scripts that are being run, or you have a Spark query that you're running, some Spark jobs that data scientists are working on. We can also put in our logging APIs there and help to stitch together how things on the Airflow side or the production side are relating to things within research or experimentation.
Nice, great. I had a couple of questions myself. I'm curious which slice of the monitoring pyramid for you is the most challenging to implement. You could talk about for the end user to implement themselves, and I'm curious if it matches up with the challenge for you guys in building the product.
Yeah, it's an excellent question. So I think from an infrastructure perspective, the real challenge here is stitching together these remote silos of metadata, these remote metrics, in a way that makes sense to users. So being able to say, here's what your high-level Airflow pipeline looks like, here's the stuff that Airflow is running, here's what's happening in Spark, here's how users are accessing that information. and being able to pull all those silos into a context that makes sense from a organizational and usage standpoint and a logical standpoint of how these things are interconnected. That's the tough thing here, infrastructure-wise. In terms of like discrete monitoring, probably what's most challenging is the data sanity and data trends aspect. Being able to pull out like generic monitoring information about data that makes sense to as many people as possible. I showed this portion of our product where we are pulling out histograms, right, from processes and reporting on those. Even the way that histograms get set up, it might not appear this way when you see a quick demo and you see all these nice, pretty graphs on our UI, but this is definitely an area where every team looks at their data differently, and the way that you bin this information might be really unique across organizations, or what profiling information makes the most sense to you to pull out and monitor can be really, really different. So, and that's just within this histograms example, right? So finding clear, generic, generally purposable ways of monitoring the data sanity is definitely a ripe area for product work and an area where a lot of our clients are interested in. What we do today to try to address some of that challenge is, first of all, we try to, for lack of a better term, offload a lot of the intelligence that we need into the trends that we see coming from our users' executions. So we don't necessarily, if we're trying to look at like one of these histograms and say, hey, this histogram looks really weird, that's basically impossible for us to do. But when Databand collects the history of all these profiles and can combine that with stuff that we're seeing upstream and how that relates to issues that we're seeing downstream and the lineage within each of these pipelines, it's actually not the biggest challenge to flag users when like there's obviously something wrong. Like we see that there's a data frame here which is totally empty, or a column which is totally empty, or like I showed, there's this data frame which has a bunch of imputed values where they're all 0, and we've never seen that before within the system. This kind of functionality is, we feel like, the short tail that we can bring in and kind of knock off a good amount of monitoring issues right up front. But definitely an area of interest for us.
Is there an underlying open source project that's powering that data trend section, or is that all part of Databand's work?
That is part of Databand, though with all of these different monitoring pieces, we do see the interest of expanding out how we collect information and being able to plug in different open source libraries. So for example, when we operate in this Spark world, we see a lot of ML flow. ML flow is another tool for collecting out metrics from jobs. It doesn't really understand what's happening at the DAG level, and it doesn't know what's happening in Airflow, and there's a lot of work that you need to do to pull it in to the data context, but it's one small piece of this puzzle. And what we can actually do is we can just hook our API directly into the MLflow library. If you already have MLflow metrics annotated or instrumented within your pipelines, you can just send those to us right away. That would be one example of where you can extend our product to collect more kinds of information. Another example is if you're using some custom data profiling library or something like Pandas Profiler, you can also connect that into our API and we can collect all that information out. Where we really see Databand operating is this high level bird's eye view. How do all my pipeline pieces of my pipeline infrastructure fit together? If I want to do deeper levels of metadata collection or deeper levels of instrumentation, or I already have some library that's doing some data checks for me, we just want to plug into those directly.
Cool. A couple more questions have popped in. How easy is it to add custom data quality checks to Databand?
It depends what you are looking for, but the easiest way that this could be done is leveraging the automated data quality checks that we bring into the product. So An example of that would be these histograms. All I need to do in order to track my data quality through histograms is tell Databand that I want to log a histogram when my pipeline executes. So within my Python code or Java code or Scala code, I would just say, log data frame if I'm working with data frames, and that'll get sent into our system. Once we collect out the data frame, we can extract out these histograms, present the information to you cleanly within the UI. That would be like a very clean, easy way of getting some of this profiling information out. If you want to customize that, we also have obviously really easy ways of customizing it. So we can, if we're talking about the histogram level, customize how we're pulling out the histogram or the binning of the histogram or the exact metrics that we're pulling out and encapsulating into those reports. Another maybe even simpler thing that we can do is, TrainModel is a good example here. So R squared and RMSE, actually I can go into a pipeline. Let me see if I have an example here that shows a data quality metric. Let's see, I'm in my metrics table here. Right, so I have data shape here, which is, it looks like describing my columns within my data set. And this raw shape, not the greatest, most readable annotation here, but that would be a custom metric that I've written into my code. So I just said, I want to calculate my number of columns here when I operate on this data frame, and I want to log that as a metric into Databand. So that's also fairly easy to do, just involves some work with the SDK. That is a way, by the way, of standardizing the data quality checks that you want to embed into your pipelines using that SDK that we offer, DBND. Once that's instrumented, we can log all this information. It can get pointed into Databand's application, and we can monitor and alert on this information. But that's as easy as calculating the metric, logging it into Databand system whenever I run my pipeline code or Airflow runs my code.
Great. I think we have time for maybe just one more question. It's kind of a big one, though. Can Databand help me with data lineage? So I'm curious if you're thinking about that.
Yeah, it's another great question. So I like to always start with these kinds of big questions. What do we mean by data lineage? But if we're talking about being able to trace how inputs and outputs between pipelines work and what part of my pipeline is reading data sets produced by other parts of my pipeline. I'll revert back to my example here, which will do a better job of explaining this than I will. But throughout this pipeline, we are tracking input and output of the process. You can see I have a number of functions here that Airflow is running as part of this task. And if I start from my outermost task, you can see we have a data set. That's what the data set looks like. If I go to a previous task, you can also see we have a data set. Going into a previous task, you can see we have a data set. And finally, we have another data set, right? So we can see that data lineage throughout the pipeline that's running, okay? What we can also do, and what I was showing in the demo, is we can see how the lineage of different DAGs fit together. So I have this button that I can click into next to my data path here. Clicking into that button, I can see with this target operations table that CSV file that I'm reading from my training process is being written by this other pipeline called ingest data for AutoLab. And I can go into that pipeline and see over there, there's a bigger one, a little more complicated one. Let's zoom out here. Collapse here. So you can see here, actually I want to open that up. This is the resulting data frame, or the resulting object that will ultimately get moved into a CSV that we're reading from that other pipeline. So in this way, we do stitch together the lineage both between tasks of a given pipeline and pipelines within an overall environment or an overall organization. Okay, so we can draw that lineage. And where this gets really cool is if I have a failure in some upstream process, I can trigger an alert that tells me, based on the failure, what is going to happen in a downstream process before that pipeline even starts to run. So if I wanted to set these alerts up proactively, I could do that where, I know that my training process expects a certain kind of data. If that data doesn't appear within this upstream process, alert me on it, tell me not to ever run my training process, and have someone go and fix the problem or rerun the pipeline on an earlier partition of data. I could set up different levels of automation there that might resolve the problem automatically for me. But it's exactly this kind of area of how we want to move teams into more of a proactive stance to address a lot of the issues that we talk about with this observability pyramid.
Great. All right. Well, thanks, Josh. I think we're out of time. Appreciate your sharing all these great things. I didn't know people were curious to know. There was one final question: is there a plan to contribute some of this stuff back to OSS Airflow? So maybe just close it out with, maybe if there is some plan to, what's the next thing you might contribute to Airflow, if anything?
Yeah, excellent question. So me and Rai were actually just talking about this before the call. We do have ambitions of moving certain functionalities into Airflow. I mentioned early on in the call that the main priorities that we have for us within Airflow that we want to push would be around helping the system get better performance, making it easier to write DAGs, which we feel like will open up a lot of new use cases for Airflow, especially around machine learning, and bringing more data awareness into the system. So I think we probably need a little more discussion around the data awareness side to know exactly what the next features that we want to push in on that category would be, but definitely around performance of the system, making it easier to construct pipelines. There's more work that we want to do there and help the community out.